So section 5 in chapter 10 is called trigonometry and area. And we're actually going to kind of look at it in two parts. The first part is a continuation of section 3 where we talked about areas of regular polygons. But instead of just looking at areas of regular polygons when we have a 30, 60, 90 triangle, we're going to look at it when we don't have a triangle where we can use our triangle shortcuts. We're going to have to use trig or SOHCAHTOA to solve. That's going to be the first part. The second part, we're going to look at how to find the area of a triangle if we're not given the height, but if we're given two sides and the included angle. So those are kind of the two sections we're going to look at here. So to get started, we're given here a regular nonagon. Remember, nonagon has 9 sides. And we know that we've got a side length of 10 centimeters, and we're asked to find the area of this nonagon. So just as a refresher, from section 3, our area is equal to half times the apothem times the perimeter. So knowing that I've got a side length of 10, I can just go ahead and find my perimeter right away. We're going to do that and get that out of the way. It's got 9 sides and each side is 10 centimeters long, so our perimeter is a total of 90 centimeters. Now the apothem, remember, goes from the center to perpendicular on this side. And that's actually going to be CS right here. And I'm going to take what they've kind of sketched in here at dotted lines, and I'm going to just draw it nice and big over here after the side in a triangle, just so I have lots of room to write and fill in everything I need to find that apothem. So I'm going to label it the same. C is going to be up at my vertex, P and R on the bottom, and I'm going to sketch in my apothem. Comes in perpendicular, so we're creating that right triangle, and that's point S. Now, I'm going to look at just half of this triangle here in pink, and I'll highlight it in dark green. Let's look at CPS. I could look at the other half if I wanted to instead, CRS. It doesn't matter, but I'm going to look at this left-hand side here. And I'm going to start by finding the angle measure of this kind of top angle here, PCS. And this is what we did in section 3. I'm going to begin by finding the angle measure of the whole kind of pizza section there. Find the angle measure of angle PCR the exact same way we did in section 3 by taking 360 and dividing it by the number of those pi pieces we would have. Since it's a nonagon, it's 9 sides, we'd have 9 pi pieces. So that whole angle there is 360 divided by 9, or 40 degrees. So this whole angle is 40 degrees, which means this angle is half of that, or 20 degrees. Now, I'm going to go back to what we did in the last chapter when we looked at learning that trig, SOHCAHTOA, and I'm going to use this 20-degree angle, and I'm going to label my sides. Across the 20-degree angle is my opposite, and remember here, this dotted line from C to S, that was my apothem. That's what I'm looking for. I need to know that length in order to find my area. So, if this opposite side here, or PS is my opposite, then CS is my adjacent side. And just as a refresher, if you need to write this down at the top of your page, SOHCAHTOA, I need to figure out whether I'm going to use sine, cosine, or tangent to find that apothem. Well, looking at what I know here, I don't know either my opposite or my adjacent, so I'm going to need to go ahead and find one of those before I can use my trig. So one thing I don't have included yet in my triangle is the fact that this nonagon has a side length of 10, which means from P to R is 10. And if P to R is 10, then P to S is half of that, again, just like we looked at in section 3. So the opposite side has a length of 5. So I know the opposite side length, and I need to find the adjacent, so I'm going to use tangent. And that's going to look like this. Tangent of my angle, which is 20 degrees, equals opposite, 5, over adjacent. We don't know that. That's my variable A. Now I've got one variable here I can solve. Put tangent 20 over 1, cross multiply. And we get A times tangent of 20 equals 5. Now remember, tangent of 20 is just, it's some number. It's a long, nasty, irrational number, but it's just some number. So I'm going to divide both sides by tangent of 20 to get that A by itself. So make sure that you've got a calculator that can do those trig functions, and make sure you're in degrees. If you're using the calculator here, it's going to look like this. And let's go ahead, oops, that's not what I wanted, clear that out. We want to figure out what 5 divided by tangent of 20 is. So 5 divided by, in my calculator, I put in the 20 first, then I select tangent. Yours, you may do tangent first, then 20, and enter. And we're going to want to go out at least 3 decimal places here. Since we have a lot of rounding going on, if we only go to 1 decimal place, we're going to end up with a value that could be a couple too high or too low. So we always want to make sure we round at least to 3. If you want to go more, the more you go, the more precise you'll be. So we're going to say that our apothem is equal to 13.73, approximately. So it's not a nice number, but it's still a value that apothem is equal to. So now that I've got my perimeter, which we found in the beginning to be 90, and my apothem, I can just plug in the rest to find my area. Area equals 1/2 times your apothem, 13.73. Oh, I wanted to do 3 decimals, because I think that was a 7, right? Yep. And times the perimeter, which we said was 90. Now, one trick that I would tell you to do, if you can, so we just found this in our calculator, leave that in there and just keep using that to continue on to find your area. So instead of clearing out the calculator, I'm just going to take that value, put times 1/2 or 0.5 times 90. Okay, so that's going to give me as exact answers as I can. Then I didn't have to do any rounding till the very end. And that's approximately 618 centimeters squared. So if you cannot clear out any rounded values, you're going to get a more exact answer. All right, let's try one more like that. We're asked to find the area of a regular pentagon that has 4-inch sides and round your answer to the nearest square inch. But again, don't do any of that rounding to the nearest whole number until we're all the way finished. So here's my pentagon, and I know that I've got 4-inch sides, and I'm going to do the same thing I started, just like in section 3, and draw that triangle. And let's find this angle measure first. To do that, we're going to take 360 divided by those number of pieces of pie we'll have, or the number of sides we have, so 360 divided by 5, and that angle is 72 degrees. So now I'm going to go ahead and sketch my triangle larger over here, so I've got lots of room. I'm going to sketch in my apothem, and if this whole angle at the top is 72, then just half of that angle must be 36. And again, if I've got 4-inch sides, so from the left to the right here is 4 inches, then half of that is 2 inches if we're just looking at this right triangle here. Bear with me, it's rather messy, but. So, just like in the last problem, I'm going to need to use some trigonometry, SOHCAHTOA, to figure out my apothem. Across from the 36 is opposite. I'm looking for this apothem here, which is my adjacent side. So if we want to, we can review our SOHCAHTOA. And again, we're going to choose tangent, so that we have the opposite and the adjacent. So we're going to say tangent of 36 equals my opposite side length, which is 2, over my adjacent, which is A. Again, put your trig function over 1, cross multiply. We get A times tangent of 36 equals 2 times 1 is just 2. Isolate that A by dividing both sides by tangent of 36. So in our calculator, 2 divided by 36, tangent, enter. Again, at least give yourself 3 decimals or leave it in there so we can use that as we continue. 2.753 approximately. And if we remember, to get our area of a regular polygon, we need our apothem and our perimeter. So let's find our perimeter here quick. Perimeter is going to be our side length, which is 4, times the number of sides we have. It's a pentagon. We've got 5 sides, so our perimeter is 20. So our last step here is just going to be plug and chug into that area formula. 1/2 times apothem, which we said was approximately 2.753, times the perimeter, which is 20. And we want to round to the nearest whole number. So again, I'm going to just leave this value in here, this long, nasty value we got from taking 2 divided by tangent of 36, multiply it by half, multiply it by 20. Enter, and we get rounded to the nearest whole number, about 28. What's my units here? 28 inches squared. So kind of just one more step than what we had to deal with in the last section, section 3 when we did this. I'm setting up those SOHCAHTOA, or those right triangles, to find missing side lengths. Now the next problem we're going to do, we're actually going to have to do that twice. So it says here a stop sign is a regular octagon, and the standard size has a 16.2 radius. We want to find the area of the stop sign to the nearest inch. So radius actually refers to from the center to the vertex. And if you remember, we defined this term, the radius of a regular polygon, in section 3 as well. So all we're told here is that this length is 16.2. So I'm going to go ahead, and that's I know a little bit hard to see, sketch a triangle over here off to the right, just like I always do. And draw on what I know, this is 16.2. Notice, if I sketch in my apothem, perpendicular from the vertex, now I know the hypotenuse of my right triangle instead of the opposite side like I've been given in the last two problems. So we can still find our opposite side and our apothem. We're just going to need to do this in kind of two separate steps. Before we can do any of that though, we do need to know this angle. So I'm going to start again, just like I have in the past, by finding the large angle and then dividing by 2. So to find the measure of a central angle there, we take 360 divided by the number of sides we have, 8. 360 divided by 8 is 45. That means this whole angle here is 45 degrees, so half of that is 22.5. Now, we're going to do this kind of step by step here, and we're going to start by finding, I'm going to label this here x. Once I find x, I'm going to go ahead and continue on to find my perimeter, because right now I don't know enough information to get that perimeter. Once I get x, I'll find my perimeter, then I'll go back and I'll find my apothem. Once I have my perimeter and my apothem, I can solve for my area. So here's the angle I know, 22.5. This x is my opposite side, and 16.2 is my hypotenuse. So if I write down SOHCAHTOA again, we want to find the one that uses the opposite and the hypotenuse. So in this case, we're going to be working with sine. And we're going to have sine of my angle, 22.5, is equal to opposite over hypotenuse. Opposite is x, hypotenuse is 16.2. And cross multiply, we get x is equal to 16.2 sine of 22.5. We don't have to do any algebra to get the x by itself. We just need to put that into our calculator. And again, give me at least 3 decimal places here. So 16.2 times 22.5 sine and enter. About 6.199. You can go more, don't go less than 3 decimal places. So what did we just find? We just found that this length here, half of the way across the side, is 6.199 inches long. Now to find the perimeter, I need to find how far it is all the way across. Once I know the side length, that's like finding kind of this bottom portion here, and that's going to be my S. Once I find the side length, then I can find the perimeter by multiplying by 8. So just like in the past where we took our side length and divided by 2 to find the side of my triangle, we're going to work the other way this time. 6.199 is halfway across that side length, so we're going to take that and multiply by 2 to find S. 6.19 times 2. My side length is 12.398. So that's like saying any one of these sides is about 12.398 inches long. So my perimeter then is going to be that side length, 12.398, times the number of sides I have. It's an octagon, so I've got 8 sides. 12.398 times 8. My perimeter is about 99.184. I might have to squish it in here. And we'll use that here in a second when we find our area. Now I said once we get our perimeter, we're going to go back to that right triangle and we need to find our apothem. So now my apothem is here. If I'm looking at this angle 22.5, notice that's my adjacent side. And I could use the opposite and pick tangent, but that's a number I've already rounded and I'd rather not work with a number I've already rounded. So I'm going to go ahead and pick the one that uses the hypotenuse and the adjacent side. I'm going to be using cosine to find my apothem. Cosine of my angle, 22.5, is equal to my adjacent side, which is just A, over my hypotenuse, which is 16.2. And just like we did in the previous step, we're going to cross multiply. A, or our apothem, is equal to 16.2 times, oops, not sine, but cosine of 22.5. And when you put that in your calculator and you round to 3 decimal places, you get about 14.967. So our final step here is just going to be to take all of that and plug it into our area formula for a regular polygon. Area equals 1/2 apothem, which we said was about 14.967, times your perimeter, which is about 99.184. And if you do have more decimal places there, it's just going to get you a more exact answer. So there's our perimeter times half times our apothem of 14.967. And we are asked to round to the nearest whole number, so we have about 742 square inches. So a standard stop sign has an area of about 742 square inches. So when you approach these problems where you're only given one value, and specifically if it's that hypotenuse value or that radius of your regular polygon, take your time, draw your pictures, find the side length, find the perimeter, and find the apothem. Give yourself plenty of space, and certainly don't try this without drawing a picture. So that was the first part I said we talk about, finding the area when we're not given a nice 30, 60, 90 triangle. The second part I said is we're going to find a new formula for the area of a triangle and use that when we don't have a base and a height. So we're told here in Theorem 10-8 that the area of a triangle is half the product of the lengths of two sides and the sine of the included angle. That's a lot going on. Really what we just need to know here is that the area of this triangle is equal to half BC times sine of A. And what's important here, so BC would be my side lengths, B and C. Sine of A, we always have that be an angle. So what we know here is that this works only when we have side angle side. If I know two side lengths and the included angle, I can use this formula to find my area without knowing the base and the height. So here in problem 3, always check to make sure you're given the right thing before you go ahead and try to use that formula. I've got two side lengths, 12 and 21, and 48 is the included angle. Remember, to find if it's included, sketch each side. Are you creating that angle? I am. So I can use this. Now B and C, it doesn't matter which you choose to be which. I'm going to call 12 to be B and 21 to be C. So I'm going to pull that formula. Area equals 1/2. B is 12. C is 21. Sine, we always use an angle with the trig function of 48. And that can go straight into your calculator as is. 1/2 times 12 times 21 times sine of 48. Sine and enter. And it doesn't tell me here what to round to. Let's just go to the nearest whole number, about 94 square centimeters. So once we know those values, it's pretty much straight plug and chug. Let's try one more like that. Again, it doesn't matter what you choose to be B, what you choose to be C, but we do have two side lengths in the included angle. So I'm going to say area is equal to 1/2 times B is 10, C is 16, times sine of 34. And plug that all in. And when you do, you get approximately 45 square inches. So those are pretty nice, straightforward, as long as you have a side angle side triangle. So if you have questions on any of that, I know that the trig can be a little bit tricky in those first problems. Shoot me an email and I'll be happy to go over it with you.